In this problem, we're targeting an amount of 0.7 moles of chloride ions, and the source of the chloride ion is iron 3 chloride, so we have to write the dissociation reaction to start. So we have iron 3 chloride put in water, dissolving. We end up with an iron 3 plus and 3 chloride ions in aqueous solution. We know that the charge on the iron is 3 plus because it has to balance out the minus 3 from the 3 chloride ions. Now we want to obtain 0.70 moles of chloride ion. But our solution contains iron 3 chloride, so we need to relate iron 3 chloride to the amount of chloride ion, which is why we wrote the dissociation reaction. So every unit of iron 3 chloride is going to give us 3 units of chloride ion. This allows us to cancel out units of chloride ion and know how many moles of iron 3 chloride we need to obtain. Now we can use our molarity as a conversion factor because we know 1.1 moles of iron chloride is equivalent to a liter of solution. So if we check our units here, moles of iron 3 cancel out with moles of iron 3, and we end up with liters of solution. So the math that we set up comes out to 0.2121 liters as our calculator answer. We look at sig figs. This is exact, so it's not going to affect the sig figs. And this has 2 sig figs, so we're limited to 2 sig figs. Our final answer is 0.21 liters. In this problem, we want to obtain 0.6 moles of sodium plus ions from this solution. So we're going to have to write our dissociation reaction since our source of sodium ions is our sodium phosphate. So we have sodium phosphate dissolving in water. That's going to give us 3 sodium plus ions and 1 phosphate ion. So we're targeting 0.600 moles of sodium ions. Our dissociation reaction tells us that we get 3 moles of sodium ion for every mole of our solute. So now we know how many moles of our solute we need to obtain that targeted amount of sodium ions. And again, we can use our conversion factor to obtain our answer. So 1.60 moles of our solute is equivalent to a liter of solution. So let's check our units here. Moles of sodium phosphate cancel out, and we have our final answer in liters of solution. We do our math, and this comes out to be 0.125 liters. Let's look at our sig figs. 3, this is exact, so it doesn't affect sig figs. This has 3 sig figs, So we're good with this answer as it's written.